Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is the brilliant Victor. Today we're diving into the fascinating world of concurrent collections, specifically the CopyOnWriteArrayList. Victor, are you ready to unravel this intriguing data structure?
Absolutely, Sheila. I'm excited to explore CopyOnWriteArrayList with you and our listeners. It's a unique implementation that solves some specific concurrency challenges.
Great! Before we dive in, let's set the stage for our listeners. We're currently in the third season of our series, focusing on concurrent collections. We've just finished discussing maps and sets, and now we're moving on to copy-on-write collections. To kick things off, I have a quiz question for our audience. In what scenario would you prefer using a copy-on-write array list over a regular array list with synchronized methods?
Ooh, that's an excellent question, Sheila. It really gets to the heart of why CopyOnWriteArrayList exists. Listeners, take a moment to think about it. Consider the performance characteristics you might need in a concurrent environment. We'll reveal the answer at the end of the episode, but for now, let's lay some groundwork.
Sounds good, Victor. Let's start with the basics. Can you give us a brief overview of what CopyOnWriteArrayList is and why it was created?
Certainly. CopyOnWriteArrayList is a thread-safe variant of ArrayList in which all mutative operations, that is, operations that change the list, like adding, setting, or removing elements, are implemented by making a fresh copy of the underlying array. It's part of the java.util.concurrent package and was introduced to address specific concurrency scenarios where read operations are much more frequent than write operations.
Interesting. So it's like having a special list that creates a new copy every time you want to change it. That sounds potentially expensive. How does this approach make it thread-safe?
Great observation, Sheila. You're right that it can be expensive for writes, but that's part of the trade-off. The thread safety comes from the fact that the internal array is never modified. Instead, a new array is created for each update operation. This means that read operations can happen without any synchronization, making them very fast and allowing multiple threads to read simultaneously without contention.
I see. So it's optimized for scenarios with lots of reads and infrequent writes. Can you give us an analogy to help visualize how this works?
Absolutely. Think of CopyOnWriteArrayList as a collaborative whiteboard in a meeting room. When someone wants to add or change something, instead of writing directly on the board, they take a picture of the current board, make their changes on a new board, and then replace the old board with the new one. This way, people can always look at the board without worrying about it changing mid-read or needing to wait for someone to finish writing.
That's a great analogy. It really helps to visualize the process. Now, I'm curious about the performance implications. How does this copy-on-write strategy affect read and write operations?
Excellent question. Read operations are extremely fast because they don't need any synchronization. They simply access the current array without any locking. However, write operations can be costly, especially for large lists, because they involve creating a new copy of the entire array. This is why CopyOnWriteArrayList is best suited for situations where reads greatly outnumber writes.
I can see how that would be beneficial in certain scenarios. Can you give us some real-world examples of where copy-on-write-ArrayList might be used?
Certainly, one common use case is for maintaining lists of event listeners in event-driven programming. Listeners are usually added or removed infrequently, but the list is iterated over frequently to notify listeners of events. Another example might be a cache of relatively static data that's updated occasionally but read frequently by multiple threads.
Those examples really help to contextualize its use. Now I'm wondering how copy-on-write-ArrayList compares to other list implementations. What are the key differences between copy-on-write-ArrayList and, say, a synchronized array list?
Great comparison point, Sheila. The main difference is in how they handle concurrency. A synchronized array list uses a lock for both read and write operations, which can lead to contention when multiple threads try to access the list simultaneously. CopyOnWriteArrayList, on the other hand, allows concurrent reads without any synchronization, making it much more scalable for read-heavy scenarios. However, writes are more expensive in CopyOnWriteArrayList due to the copying overhead.
That makes sense. It seems like choosing between them would depend on your specific use case and the ratio of read-to-write operations. Are there any common pitfalls or misunderstandings developers should be aware of when using CopyOnWriteArrayList?
Absolutely. One common misunderstanding is around iterator behavior. Unlike most other collections, the iterator for CopyOnWriteArrayList is guaranteed to reflect the state of the list at the time the iterator was created. It won't throw concurrent modification exception, but it also won't see any changes made to the list after its creation. This can be surprising if you're not expecting it.
That's a crucial point to remember. It sounds like developers need to be mindful of the trade-offs and specific behaviors when choosing to use CopyOnWriteArrayList. Do you have any best practices or tips for using it effectively?
Definitely. First, use CopyOnWriteArrayList when your use case aligns with its strengths, many reads, few writes, and when you need thread safety. Second, be cautious with large lists, as the copy operation can become expensive. Finally, if you need to perform multiple updates, consider using the add-all or remove-all methods instead of multiple individual add or remove operations to reduce the number of copies made.
Those are great tips, Victor. Now, before we wrap up, let's return to our quiz question. In what scenario would you prefer using a CopyOnWriteArrayList over a regular array list with synchronized methods?
Excellent. The ideal scenario for CopyOnWriteArrayList is when you have a list that's frequently read by multiple threads but rarely updated. The event listener list we mentioned earlier is a perfect example. In this case, CopyOnWriteArrayList would provide better performance than a synchronized array list because it allows for concurrent, lock-free reads, which is crucial when you're frequently iterating over the list to notify listeners.
Thank you, Victor. That wraps up our discussion on CopyOnWriteArrayList. To summarize the main points: 1. CopyOnWriteArrayList is a thread-safe list optimized for scenarios with frequent reads and infrequent writes. 2. It achieves thread safety by creating a new copy of the internal array for each write operation. 3. Read operations are very fast and can occur concurrently without synchronization. 4. Write operations can be expensive, especially for large lists. 5. It's commonly used for event listener lists and read-heavy caches. 6. The iterator provides a snapshot view and doesn't reflect subsequent modifications to the list. In our next episode, we'll be discussing CopyOnWriteArraySet, another member of the CopyOnWrite family. Stay tuned.
It's been a pleasure discussing CopyOnWriteArrayList with you, Sheila. I hope our listeners found it informative and engaging. Remember, understanding these specialized collections can really level up your concurrent programming skills.
Absolutely, Victor. And to our wonderful listeners, if you enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue creating in-depth educational content. Until next time, happy coding.